Question 14, part A, is about finding integers given the statement of inequality. So given that x is an integer and an integer is a whole number, that's what the word integer means. So x is a whole number such that, and I read this statement always starting at the x, so x is greater than -2, but x is smaller than or equal to 3. So the fact that that has only got a larger than sign means it cannot be equal to -2. So I'm going to list first of all what this one can be equal to. So it cannot be -2, it can be -1, it can be 0, it can be 1, it can be 2, and it can be equal to 3 because it's got the double line. Now y is an integer such that y is greater than or equal to -1 and y is smaller than 5. So this time it cannot be 5, but it can be -1. So -1, 0, 1, 2, 3, 4, and it can't be 5. So the final condition is that y is equal to x. Write down the possible values of x. Now if it's got to be equal in the y and in the x limit, then that means any of those, because they occur in each other's lists, can be the possible values of x. That can't be, because it's only a value of y. So the final answer is going to be -1, 0, 1, 2, 3. It's a 2-mark question. You get 1 mark for listing either the possible solutions to that inequality or the possible solutions to that. Then you get the 2nd mark for listing the correct values. Question 14b is about shading the regions of a graph defined by inequalities. So on the grid below, show by shading the region defined by the inequalities. So we've got the limit of y is greater than 1. We've got y is less than 2x minus 2. We've got y is less than 6 minus x. And we've got x is greater than 0. Now there's a couple of things you need to remember whenever you're defining regions of graphs. And that's if it's, greater than or equal to, then you're going to use a solid line. So if it can be equal to, then it's a solid line. If it cannot be equal to, then you use a dotted line. Okay, and that's if it's not, if it cannot be equal to. So because all of these are not equal to's, they would all be dotted lines. The first region I need to identify is the region where all y values are greater than 1. So I need to go to the y-axis to where it's equal to 1. Now, because it cannot actually be equal to, I need to mark this in with a dotted line. So that is the line there where y is equal to 1. However, I want the region where y is greater than 1. So I want anything up this side of the line, because everything up here, the y value is going to be greater than 1. Anything down here I'm not interested in anymore because the y value is going to be less than 1. Next I'm going to deal with this one, which is y is smaller than 2x minus 2. Now I need to draw this line in. If I draw it in first, then deal with the fact that the y values need to be lower, then that's definitely the easiest. Now some people are going to be able to draw that using the line, so they'll know it has a y-intercept of -2, and they'll know that it has a gradient of 2. But if in doubt, always do a little table of values. So I'm going to do one over here. I want my x values and my y values. Now to draw a straight line, and I know it's a straight line because it has no powers, so to draw a straight line I only actually need 2 points. So I'm going to use the point where x is 0, and then I'll use the point where x is 4. I've just decided to use those 2 numbers. You could use any 2 you wanted. So the first thing I want to find is the y value for this equation. So we've got y is less than 2x minus 2. 2x minus 2. So I'm going to substitute that in. 2 times 0 is 0. Take away 2 is minus 2. And then 2 times 4 is 8. Take away 2 is 6. So there are my 2 points in order to draw that line in. The first one is 0, negative 2. So 0, negative 2. And then the next one is 4, 6. 4, 6. So now I've got those 2 points, I can join them. And that'll give me my straight line. And again, this cannot be equal to, so it's a dotted line. Now I need to deal with which region I'm interested in. So I want the area where y is less than that line. So if you look here, it's going to be anything underneath the line is where y is going to be less than. So I'm interested in all of this area here. I'm not interested in anything up here anymore. So that's my second one done. Oops. There. Now I'm going to do my third one. And that's y is less than 6 minus x. So I'll use the same values for x. And here I'll do y is less than 6 minus x. So when x is 0, y is equal to 6 take away 0, which is 6. And when x is 4, y is equal to 6 take away 4, which is 2. So my first coordinate point of this line is 0, 6. And then I've got the coordinate point of 4, 2. So 0, 6, and 4, 2. So I'm going to add that line in. Again, it cannot be equal to, so it's a dotted line. And I'm interested in the points on that line where y is less than the line, so it's anything underneath the line. And then my final one, I'm only interested in values where x is larger than 0. So this is where x is 0 on the y-axis, and I'm interested in points over that side because this is where x has a positive value. So now I need to shade the region. This looks a bit confusing, but remember it's got to be above this first line. So it's got to be up here. It's got to be below that dotted line and below that dotted line and over this side. So that leaves me with this as my shaded region. And they very specifically tell me to mark this region with the letter R. So there's my region. For this, it's a 4-mark question and the marks are allocated. You get 1 mark if you've drawn any 2 of the lines in. So you get 1 mark for drawing any 2 of the lines. You get the second mark if you've drawn any 2 of the lines in and at least one of them shows a direction where your region is or isn't. Your third method mark is for having at least 2 lines drawn with a region indicated, so the arrows are a shading in or out, and then you get the final answer for getting the correct region. Question 15 is a vector question, and the way vectors work, you can think of it as sort of a road map where the points A, B, C, D and O are all towns, and the lines which have a directional arrow on is the name of the road, and they're one-way roads, so you can only go in the direction of the arrows. If you do go in a direction opposite to an arrow, then it becomes a minus. So A, B, C, D is a parallelogram. The diagonals intersect at O. OA, and it's written as OA with an arrow above it, and that's saying you're going from O to A. That's why it's got that arrow on. So OA is lowercase a. OB is lowercase b. Write an expression in terms of A and B for C to A. So I want to go from C to A. Now that's a direct road, and hopefully I can see that from there to there has a value of A, And because this is the centre of the diagonals of a parallelogram, this is exactly the same length. So this is also an A. So to get from O to A, I need to go along the A road and then along another A road. So I'm going to end up with an A plus an A, which is 2A. Now I want to go from B to A. So there's B, there's A. This is an unmarked road, so I cannot go along it. I don't have a value for it yet. So in order to get there on named roads, I have to go down there, which is against the B. So that goes down as a negative B. And once I've gone down the negative B road, I can add an A on to go up there. So negative B, add A. Now, the negative floating around at the start of an expression is quite dangerous. So let's rewrite it as positive A, negative B. It's exactly the same thing, but the negative is enclosed. So that is actually the name of that road there. That's the road A minus B. And then we want to get from B to C. So from B to C, again, it's an unnamed road, but I can go along there, negative B, and then along there, which is negative A. So negative B, negative A. I wrote the A first over here, so I'll do it again. It doesn't matter. Negative A, negative B. And that is the name of that road there. So they're 1 mark each. You either got them right or wrong. Now, for the second part, X is the point such that OX equals 2A minus B. Find an expression in terms of A and B for the line AX. Now, looking at our diagram, this has got potential to get quite messy. I'm going to just do a little sketch down here which copies part of my diagram. So I've got the centre of O, because it involves O. I've got this road that was going up there to A, and that was lowercase a. Now, they are mentioning a point X. I don't have a point X anywhere just yet, so I'm just going to make up my X, and I'm going to say that X is over here. So there's point X. Now, they're telling me that the road O to X, so that's O to X, is equal to 2A minus B. So it doesn't matter where X is, I'm just calling it that. From O to X is 2A minus B. They want me to find an expression in terms of A and B to get from A to X. So I want to know what it is to get from A to X. There's no road there. So to get from A to X, I actually have to go along here, which is going to be a minus A. So minus A, and then along there, which is positive 2A minus B. I can then collect and simplify there. Negative A, add 2A equals 1A minus B. So the answer is A minus B. Now, part two expects me to carry on from what my answer was to part one. And it says B, A and X lay on the same straight line. So my little sketch over here, where I had X down here and A there, it means that this wasn't drawn to scale, but it doesn't matter because the vectors work out. So I'm going to draw the sketch that they want. And they're saying that B, A and X all lay on the same straight line. So there's B, there's A. They're saying that X is going to be over here somewhere. Alright, well, what do I know first of all about the line BA? So let's have a look up there. I found the vector that BA was A minus B. So that's the name of that line. And they've told me from the I worked out in the previous question that the line from A to X was A minus B. Add them together how you like. I'm going to write it as 2A minus B. BA is equal to AX puts the two lines, BA and AX, as being parallel to one another. And we know that point A is on the line of BA and BX. So AX is parallel to BA. And then we're going to say that point A is on BA and AX. So because A is on both those lines, B, A, X are on straight line. So with regards to how the marks are allocated for this, you get 1 mark each for part A, so there's your 3 marks there. Here you get 3 marks distributed amongst the whole question. So you get 1 mark for this part, equating the line AO and OX. So you get 1 mark here. You get an answer mark. You get an answer mark for getting A minus B. And then this part is only actually worth 1 mark because you either know it or you don't. 16 is rearranging to make the subject of the formula. However, we've got brackets involved. So the first thing you always do is multiply out the brackets. Let me zoom in. So here I've got 2 times A is 2A. 2 times T is plus 2T equals 5T plus 7. Now, in order to make T the subject of the formula, I need to collect all my T's together over one side and everything else over the other. So I don't want T on both sides. What I'm going to do is identify the smallest T value, which is this one, and I'm going to get rid of it. So I'm going to take 2T off both sides. That leaves me with 2A over here, equal sign underneath the equal sign. 5T take away 2T is 3T, and there's a positive 7 there. Now I want to get that 7 away from the T, so I'm going to take that 7 away on both sides. So over here I had a 2A, now I've got 2A minus 7 equals just a 3T there. I want the T on its own, so I need to divide both sides by 3. So T is equal to 2A minus 7 over 3. It's a 3-mark question. You get 1 mark for correctly expanding the brackets. You get another mark for showing that you know somehow how to get T on its own. And you get an answer mark for getting the correct answer. Question 16 part D is to solve simultaneous equations. Now the whole aim of simultaneous equations is to get it so that either the x values or the y values end up as being equal, and then you can eliminate them. So this is my original equation 1, that's my original equation 2. Now it is easy in this case to get the x ones to balance out, but I'm just going to stick to my process and work on the y's, because whatever the coefficient of that y is, you multiply the top one by it, and whatever the coefficient of that y, you multiply the bottom one by it. So I'm going to times everything up here by 5 and everything down here by 4. So 5 times 3x is 15x, minus 5 times 4y is 20y, and that's going to be 8 times 5, which is 40. Then here I've got 9x times 4, which is 36x, positive 20y equals negative 1.5 times 4 is negative 6. Now what I've done is I've got my y values both as 20y, and one's a negative, one's a positive. In order for them to cancel out, I'd have to add them together. So I'm going to add my every part of my equation together. So 15x add 36x is 51x. Negative 20y plus positive 20y leaves me with no y's, so they've cancelled out. And that is equal to 40 add negative 6, which will give me 34. Now I solve for x, so I divide the 51 away on both sides. And that gives me x equals 34 divided by 51 is 2/3. So my x value is 2/3. Now what I need to do is substitute that x value into one of my original equations. You can choose which equation to do. I'm going to pick the second one, only because I know that that's going to be in 2/3 there, and it's quite easy to do 9 times by 2/3. I mean, that one is 3x, so it would, be just as easy, but I'm going to do the bottom one. Okay, so I'm going to sub x equals 2/3 into equation 2. So I'll start by writing the equation out. It was 9x plus 5y equals negative 1.5. So instead of 9x, it's going to be 9 times by 2/3. Add 5y equals negative 1.5. So 9 times 2/3 is 6. So 6 plus 5y equals negative 1.5. I want to get y on its own, so I need to take 6 off both sides. That leaves me with 5y is equal to negative 7.5. I need to divide the 5 away on both sides, leaving me with y equals 3/2, which, negative 3/2, which cancels down to negative 1.5. So my value for x was 2/3, so x equals 2/3 and y equals negative 1.5. And this was only a 3-mark question, so you get 1 mark up here for showing that you can eliminate either the x's or the y's. You then get the 2nd mark for showing that you're substituting your found value into one of the original equations, and you get an answer mark for getting the final answer correct. Question 17 is about similar shapes, but this time we're dealing with solid shapes. So Ali has 2 solid cones made from the same type of metal, A and B. The 2 solid cones are mathematically similar, so that means that we're always looking for a scale factor. The base of cone A is a circle with a diameter of 80. The base of cone B is a circle with a diameter of 160 centimetres. Ali uses 80 millilitres of paint to paint cone A. Ali is going to paint cone B. Work out how much paint in millilitres he will need. The first thing we're going to have to deal with is finding a scale factor. Now, in order to find the scale factor of similar shapes, you need to first of all identify a pair of corresponding sides. And in this case, we've got the 2 diameters there. And to find a scale factor, you always do the big divided by the small. So we're going to do 160 divided by 80. And that's going to give us a scale factor of 2. Now, it's a scale factor of 2 when we're dealing with length, because that's what that is. It's a conversion of the lengths. However, this question isn't about lengths. We're talking about painting one of the cones. So we're covering it in paint. When you cover something, you're actually dealing with area. And in area, anything that you have, so length would be centimetres, area would be centimetres squared. So whatever our scale factor is for length, for area, it will be our scale factor squared. So in this case, it's going to be 2 squared is the scale factor for area. Now, they've said that Ali needed 80 millilitres of paint to cover cone A. So to get from the small to the large, you just multiply by your scale factor. And my scale factor for area is 2 to the power of 2. So it's times by 2 squared. So down here, I'm going to write 80 times by 2 squared equals 320 millilitres. So that's a 2-part question. You get 1 mark for correctly identifying the scale factor, and you get the 2nd mark for multiplying it out to get the correct answer. Okay, for part B, they're talking now about volume. So part A was area, part B is volume. They're telling us that the volume of cone A is 17170 centimetres cubed. They want us to work out the volume of cone B. Now, the cones are exactly the same, and our scale factors are the same. If we were finding a length, our scale factor would be 2. When we were looking at area, our scale factor became 2 squared. But now we're looking for volume, our scale factor needs to be 2 cubed. So the volume of the small one was 171700. I need to multiply that by the scale factor cubed, and that's going to end up giving me 1373600. They're asking me about a volume, so there might be a cheeky mark available for centimetres cubed, so it's worth putting it on. However, they've already included it, so I don't get a mark for that. Always worth checking though. And this was a 3-mark question. 1 mark for correctly identifying that it's going to be 2 cubed. You get the 2nd mark for showing that you're multiplying the volume by 2 cubed, and then the 3rd mark is your answer mark.